Well, hello all. Welcome to the first day of the second semester of 2021 math analysis. All right, so this first unit is all about equations, inequalities, and then some other fundamental math units or fundamental math concepts that you're going to need to know for the semester. So some things in this unit you're going to be very familiar with, and then other things we're going to bring you to the next level of those ideas that you already know how to do. And the first one is factoring. So we're going to go over some basic factoring. I'll probably go through this pretty quickly because honestly, at this point, you should know how to factor quadratics and other types of equations. Okay, so this first one is your basic quadratic factoring, where you have to find two numbers that multiply to negative 45 and add to positive 12, with the coefficient of x squared being 1. So pretty simple. We know we have x times x, which is x squared. And then the two numbers that are going to multiply to negative 45 and add to 12 are going to have to be 15 and 3. And since I need a positive 12, then this one is going to be negative and this one's going to be positive. So basic factoring there. The second one, always, always, always remember to look for your greatest common factor. So in this case, our greatest common factor is 2. So I can pull that 2 out front, and then we get x squared minus 5x minus 24. And then we have our basic factoring pattern, multiply to negative 24 and add to negative 5, which is going to be 8 and 3. And since I need a negative 5, I'm going to make my 8 negative and my 3 positive. Just a little extension on this one. If you forgot to look for the greatest common factor, then you're probably going to go through that method where I call it split the middle term, or a lot of people at LEAD call it the M method. So this is where you multiply your two outside numbers and you get negative 96 x squared. So then you're looking for two numbers that multiply to negative 96 and add to negative 10. You probably need your calculator for this to go through your factors of 96. If you do that, then you should get negative 16x and positive 6x. That'll give you the negative 10. And you bring down your 2x squared and your negative 48. Bring down these two values that you came up with in the middle of the M. And then once you get to that part, you factor by grouping. So here I can pull out a 2x, and I get x squared minus 8. Sorry. X minus 8. Here I can pull out a 6, and I get x minus 8. So I get x minus 8 times 2x plus 6. But then if you look here, I have a greatest common factor of 2. So I can pull my 2 out front and end up with x plus 3, which is exactly the same thing that I came up with up here. So it was much quicker and much more efficient to pull out that greatest common factor first. So always look for that. Okay, so second idea of factoring is when you have 4 terms, always look to factor by grouping. So these are already written in order for you, so I can group my first 2 and my last 2. Out of my first set, I can pull out an x squared and get x minus 4. Out of my second set, I can pull out my 3 and get x minus 4. So to factor this one, I have x squared plus 3 times x minus 4, and that's all I can do with that. Okay, so for my second set here, I see a greatest common factor, so I'm probably going to do this one two ways for you. First thing I'll pull out is my greatest common factor of 3x. So I get x cubed plus 2x squared minus 2x minus 4. So then I can factor by grouping. Don't forget that 3x out front. So I can pull a x squared out of those first two terms and get x plus 2. I can pull out a negative 2 from my second set and get x plus 2. So then my full factoring form is 3x times x plus 2 times x squared minus 2. Okay, so the other way to see this one is if you see that greatest common factor, you probably would have grouped these two together and these two together and pulled out the GCF there. So if you do it that way, the first set, you're going to pull a 3x cubed out and get x plus 2. Then you'll pull out of the second set a negative 6x, and you end up with x plus 2. So then you have 3x to the third minus 6x times x plus 2. But then if you look at this binomial, you can pull out a GCF, which is 3x. And then you're left with x plus minus x squared minus 2 times x plus 2. So either way, you get the same answer. It just depends on how you start the problem. So always look to make sure you factored completely. Okay, so difference of squares is a nice pattern that hopefully we recognize. So it always has to be subtraction, and it always has to be two perfect squares. So this is a basic one, x plus 6 and x minus 6. So this one I can see that my 36x to the fourth is a perfect square, and so is my 81. So I can get 6x squared and 6x squared for my first term, and then a plus 9 and a minus 9. So out of each of those, I can pull a 3. So if I pull a 3 out of this one, I get 2x squared plus 3. And I can pull a 3 out of this one as well. Get 2x squared minus 3. So 3 times 3 is 9. Times 2x squared plus 3 times 2x squared minus 3. Really, I should practice what I preach, because if I would have pulled out my GCF of 9 before I started, I would have got 4x squared minus 9. And then this difference of squares is going to factor to that difference of squares pattern. So either way works as long as I factor completely. All right, so sum and difference of cubes is probably something that if you took college algebra, you probably saw it, and then algebra 2, you just see it briefly. So this is where you're adding or subtracting two numbers that are perfect cubes. So basically it's a pattern. So if I have a cubed plus b cubed, that's going to equal a plus b times a squared minus ab plus b squared. It's just a pattern you need to memorize. I always remember it. I have to remember my patterns with my a's and b's, but for my addition, I think about that as a plus, a minus, and a plus. So I just make a mnemonic device. Pink pigs make pork. If you had me for Algebra 2, you might remember that. Also for this quadratic that you always end up with here, that can never, ever, ever be factored. And those zeros of that quadratic are always imaginary. So for a cubed minus b cubed, I'll tell you my pattern for that one. It's going to be a minus b times a squared plus ab plus b squared. Again, this is a quadratic that can't be factored. You have to solve it using the quadratic formula. So for this one, I get a minus, a plus, and a plus. So I think of my mother paints pictures. So you can come up with your own mnemonic devices for the pluses and the minuses, the P's and the M's, but that's what I was taught when I was in school. All right, so we're going to factor these completely. So the cube root of x cubed is x, and the cube root of 27 is 9. So those are the two numbers that are going to be the A's and the B's. So this one is binomial, trinomial, pink pigs make pork. And then all I have to do is fill in my numbers. So I get an x, this should be a 3. Sorry about that. X plus 3. So then my first term is squared. My last term is squared. And my middle term is just 3 times x, which is 3x. Okay, so for this one, neither 54 nor 16 is a perfect cube. So let's factor out our greatest common factor, which is 2. See if it helps us to get to a difference of squares binomial. So I get 27x cubed minus 8. So 27x cubed is a perfect cube. The cube root of that is 3x. 8 is a perfect cube, which is 2. So for my pattern here, this is a minus, so it's my mother paints pictures. So my mother paints pictures. So this is your 3x minus 2. First term is 3x quantity squared, which is 9x squared. Last term is 2 squared, which is 4. And the middle terms are just 3x times 2, which is 6x. So there's your patterns for factoring a sum or difference of two perfect cubic numbers. All right, so let's go back to this one. The example on the factor by grouping. Okay, so I just want you to remember that when you factor out a greatest common factor, for instance, here I factored out an x squared, and I ended up with an x to the first. You're always pulling out the smallest exponent showing, and then to get this new exponent, you're taking the 3 minus the 2 that you factored out. So this is going to be important when we look at factoring these rational expressions, because this is probably something new that I'm going to doubt you've seen it before unless you did it in college algebra. Okay, so factoring with rational exponents, you need to find the smallest exponent. And then you subtract, just like you do in normal factoring. So as you can see, you're going to have to be working with some fractions. All right, so let's start off with just a basic binomial. So my smallest exponent showing here is x to the 1/2. So my greatest common factor is x to the 1/2. So now if I take my x to the 1/2 and factor out an x to the 1/2, well, 1/2 minus 1/2 is 1, so that just becomes an x. And then to get the exponent for my second x, I'm going to take 5 halves minus the one I'm factoring out, which is 4 halves, or 2. So that factors to x to the 1/2 times x and x minus 2. Actually, I kind of messed that one up, didn't I? That would be x to the 0. 1/2 minus 1/2 is 0. This is Spencer. So then I get x to the 1/2 times 1 minus x squared. Then I actually have a difference of squares pattern here. So I get x to the 1/2 times 1 plus x times 1 minus x. New year, new semester. Okay, so for this next one, I'm going to have to deal with some negatives. So my smallest exponent showing here is -3/2. That's smaller than the rest of them. My coefficients, I don't have a common factor that I can pull out. So I'm going to be pulling out x to the -3/2. So now you're going to have to concentrate on subtracting your negative numbers. So x to the 1/2, I've got x to the 1/2 minus -3/2, which is going to be 4/2, which is x squared, plus 5. And now I have x to the -1/2 minus -3/2, which that changes to plus 3, which is -1/2 plus 3/2, which is 2/2, which is just x to the first, plus x to the -3/2. Well, I pulled out the -3/2. So -3/2 minus -3/2 is going to be 0. So I get x to the 0, which is equal to 1. So if you factor out that rational exponent correctly, you should always get whole number exponents on the inside of the parentheses that you're factoring. And I don't think that quadratic can be factored again. 2 times 1 is 2. There's no numbers that multiply to 2 and add to +5. All right, so more rational exponents. Okay, so this one, my base is common. I have x plus 2 as my common base. So my smallest exponent showing here is 3/2. So I'm going to factor out x plus 2 to the 3/2. Then I'm going to be left with x plus 2. 7/2 minus 3/2 is 4/2, or x plus 2 quantity squared, minus, and if I take 3/2 minus the 3/2 I'm factoring out, I just get x plus 2 to the 0, which is 1. Okay, so we can simplify that a little bit farther. A couple ways to do it. You might see that as a difference in squares, but I think more commonly you're going to see that you just go ahead and FOIL out that x plus 2 quantity squared. So if you do that, you get x plus x squared plus 4x plus 4 minus 1. So that can be simplified to x plus 2 to the 3/2 times x squared plus 4x, and 4 minus 1 is 3. That quadratic can be factored again. X plus 2 to the 3/2 times x plus 3 times x plus 1. And now that is completely factored. Okay, so this next one, well, my smallest exponent showing would be x to the 0. So that's not going to work out very well when I take my rational exponents and subtract 0. So on this one, believe it or not, we're going to use this M method. Okay, so if I multiply both of those A and their C values, I get negative 24 x to the 4/3. So then I have to look at that number just like I do always, split the middle term. And I have to think, okay, I need two numbers that I can multiply to negative 24 and add to 5, negative 5. So that would be a negative 8x and a 3x. But remember, my exponents are going to be added. So this becomes 2/3 and 2/3 because I am multiplying those. So when I add those two numbers, negative 8x to the 2/3 plus 3x to the 2/3, my exponent stays the same, just like it always does. Okay, so now I'm going to bring down that first term, 12x to the 4/3. Bring down my minus 8x to the 2/3 plus 3x to the 2/3 minus 2. So then I have my factor by grouping. I can pull out, what, 4x to the 2/3. Smallest exponent showing. So I get 3x, 4/3 minus 2/3 is 2/3. And then if I pull out I get a minus 2. 2/3 minus 2/3 is 0. So that's just 3x to the 2/3 minus 2 plus 1 times 3x to the 2/3 minus 2, which is 4x to the 2/3 plus 1 times 3x to the 2/3 minus 2. Now, wasn't that one fun? All right, so one last one. Here I have my 4 terms, so I look to factor by grouping. So from this first one, I can pull out a x to the 2/5, smallest exponent showing. And then I would be left with x to the 1/5 plus 5. Here I can pull out a negative 3. And I get x to the 1/5 plus 5. So when I finish this up, I get x to the 2/5 minus 3 times x to the 1/5 plus 5. There you have it. Just when you thought in your previous years you understood factoring and you were really good at it, we get to throw in rational exponents. So you don't have an assignment yet, so you might go to maybe the resources in Summit, and there's probably some practice worksheets there that you could work on to practice factoring those rational exponents. Everybody have a great day, and I will talk to you next time.